Okay, let's do some examples of comparing radii for atoms and ions. This is part 5 to the periodic trends notes. If you are comfortable with all of this, you can skip past this video. Just check the answer key, make sure that it makes sense, that you get the same answers. And then if you get something different and need further explanation, watch the parts of the video that apply to you. So we have example explanations of radii comparison between atoms and ions. So our cation versus atom radius, we've got an example here. Which is larger? Which has a larger radius, Mg2 plus or Mg? And then we want to explain why. So let's look at magnesium and Mg2 plus. So Mg is right here, of course. It's in the third energy level. And if we were to give away 2 electrons, so it would be Mg2 plus, it would no longer be in the third energy level, it would be in the second energy level. So let's look at that. The Mg2 plus has 2 energy shells. Mg atom has 3. The Mg2 plus's ions, outermost electrons, are closer to the nucleus. Zoom in a little bit. Then the magnesium atom's valence electrons. And magnesium 2 plus's ionic radius is smaller than magnesium's atomic radius as a result. Now we have anion radius versus atom radius, negative ion. Question here is, which has a larger radius, sulfide or sulfur? S2 minus is sulfide, S is sulfur. So we want to find those on our periodic table over here. Sulfide is right here. If I wanted to get, or sulfur is right there, sulfide would gain 2 electrons and have the same number of electrons as argon. It's going to have 2 extra electrons. It's still going to be in the same energy level though. So let's look. Sulfide ion has, what row were we in? That would be the third energy level. So sulfide ion has 3 energy shells or energy levels, and the sulfur atom has 3 energy shells or energy levels. Sulfide ion has how many protons? Let's find out. It's got 16 protons. And the sulfur atom has 16 protons. They're the same number of protons, so the only thing we can talk about is the number of electrons, because everything else is the same. Okay, the sulfide ion has 2 extra electrons. The sulfur atom is going to have the same number of electrons as protons, so that's going to be 16. Sulfide has 2 extra, so it would be 18 electrons. So there is a greater or lower electron-electron repulsion in sulfide. Hopefully you saw that it is a greater, or you could say a greater amount of electron-electron repulsion in sulfide than in the sulfur atom. So sulfide's ionic, or the sulfide ion's outermost electrons are further from the nucleus than the sulfur atom's valence electrons. So sulfide's ionic radius is larger than sulfur's. That electron-electron repulsion forces the electrons to spread out. So the ion gets bigger because it's a negative ion. All right, cation radius versus cation radius. So if they're both cations, we've got to compare something a little different. Okay, so Fe2 plus ion. The Fe2 plus ion has, well, it's right here, and remember we first lose the 4s electrons because you're going to lose electrons from the valence shell. So instead of having instead of having 4 energy levels, we're actually just going to have 3 because it's lost both of those outer electrons. So we've got 3 energy shells. Fe3 plus also only has 3 energy shells. So the Fe2 plus ion has how many protons? Let's find it. The number of protons, remember, is just based on the atomic number, so that's 26 protons for both of them. 26 and 26. The Fe2 plus ion has how many electrons? Well, Fe2 plus has 2 fewer electrons than protons. So instead of 26, it's got 24 electrons. Fe3 plus has 3 fewer electrons than protons. So it has 23 electrons. Which one has more electron-electron repulsion? Fe2 plus is going to have more electron-electron repulsion because it's got more electrons. And if there's nothing else different other than the number of electrons, if it's the same number of energy levels, same number of protons, the only thing that's different is electrons, that's when you talk about electron-electron repulsion. The one with more electrons has greater electron-electron repulsion. Fe2 plus has a greater or stronger electron-electron repulsion than Fe3 plus. And Fe2 plus's ions, outermost electrons, are farther from the nucleus. It's further from the nucleus than Fe3 plus's outermost electrons. Fe2 plus's ionic radius is larger than Fe3 plus's ionic radius. So you can pretty well deduce that the more positive one will be smaller than the less positive one. But I do want you to be able to explain why. It's because you have a different number of electrons. The more electrons leads to additional electron-electron repulsion, which we use to explain if the number of energy levels is the same and if the number of protons are the same. If both of those things are the same, you have to look at the number of electrons. All right, continuing, isoelectronic atoms and ions. We want to compare the radius of a chloride ion, an argon atom, and a potassium ion. The chloride ion has how many energy levels, and then argon, and then potassium. Let's look. Okay. Chloride is in the 3rd energy level, argon is in the 3rd energy level, and then the potassium ion, remember, we're losing 1 electron, so it's also going to be 3rd energy level. So they all have 3 energy shells or 3 energy levels. The chloride ion has how many protons? Let's look. I think it's 17. 17, 18, and 19 is what we've got. Chloride is 17. Argon is 18. And potassium is 19. We're looking at protons. You see that those are different. Okay, the attractive force between the nucleus and the outermost electrons is strongest in K+, It's got more protons in that one, right? And weakest in Cl minus. And that's because potassium, the K plus ion, has more protons than the chloride ion, with just 17 protons, but they all have the same number of energy levels and they have the same number of electrons. They have the same number of energy levels, that's the key point. Okay, the outermost electrons are farthest from the nucleus for Cl minus. Whoops, I'm sorry. Missed my pen there. Okay, so the outermost electrons are going to be furthest from the nucleus for the Cl minus ions, and the outermost electrons are closest to the nucleus for the one that has the strongest attraction, which would be K plus. This seems counterintuitive because it looks like it's going against what the trend says, but when you're comparing a negative ion, an atom, and a positive ion, the only way we'll ever do that is if they're isoelectronic. They have the same number of electrons, which is what we do here. So the largest radius in this case would be the Cl minus ion, and the smallest radius would be the K plus ion. Again, it's because that having more protons pulls that electron cloud in closer with a stronger attraction to the nucleus.